So in class I was working on this and it was taking too long and I was confusing myself, so I'm going to work on it right now. The first thing that I want to do is get it into the form that I'm comfortable with, so that would be taking out the 3, so it would be x plus pi over 3, and then from there I can calculate the period. I'm eventually just probably going to end up plugging in points and seeing what I get, and then looking for asymptotes and seeing what I get, but instead of like shifting around because I kept confusing myself with that. So this part, remember, you would set equal to the original form, which would be a tangent, that's a bracket, and then pi divided by b, x minus c, and plus d, something like that. So for tangent, it's pi over b. For sine and cosine, it's 2 pi over b. So we would have pi over b equaling 3. And you switch those, solve for b, that would be pi over 3. So the period should come out to be pi over 3, and we'll see what happens. Perhaps with trig functions, because they're periodic, might not follow the shifting and same rules that I'm thinking of, or maybe I'm thinking of the rules incorrectly. So let's see what happens. If I have my graph, I'm not going to put any tick marks on it until I actually know what values I'm using. My amplitude should be -3. I'm thinking that it probably flips it over, but I don't know anymore. So I'll just plug in stuff. The first thing that I want to plug in is 0. So if I plug in 0 for my x, well, that means I get pi over 3 times 3. So that would cancel out, giving me pi. So then I'd have tangent of pi. So I'm doing this all by hand. Tangent of pi. That's the same thing as sine of pi divided by cosine of pi, because that's the definition of tangent. So cosine, and then on the unit circle, that's pi is over here. So this would be 0, this would be 1. I think in class I messed up and I said that it was 0 and there's an asymptote there. That's one of the reasons why I got it wrong. So I plug in 0, and then I get 0 for tangent. But then, so this part evaluates to 0, and then I times it by -3, of course, it's still 0, and then plus 2. So this crosses the y-axis at 2. So there we go. That's the first part. And just because I have x plus pi over 3, I'm going to plug in negative pi over 3. So that's the first thing I'll plug in over here, negative pi over 3. So if that happens, negative pi over 3 plus pi over 3, that's 0, times 3 is 0. So tangent of 0, let's figure out that. Tangent of 0. Well, that's the same thing as sine of 0 divided by cosine of 0. Sine of 0 is 0. Cosine of 0 is what? Cosine of 0 is 1, positive 1, yes, okay. So that means I get 0 again. So when I plug in negative pi over 3, I get back to, well, this evaluated to 0, times the -3 is still 0, and then plus 2. I get back to this. Some people are thinking like, what? This doesn't make sense. I thought tangent was supposed to look like this, or like this. Here's the thing. We said that our period is pi over 3. So of course we're going to get it repeating y values, because here, between here and here, is pi over 3. So I have to go a little bit smaller than this. So I'm going to get rid of that part. So let's find out where the asymptotes are. That's something that can help us out with our graph. So maybe I'll even get rid of this so I can make it more, whoops. There we go. So now I'm trying to figure out where the asymptotes are. And remember, the asymptotes are just where the bottom equals 0. When does cosine equal 0? Pi over 2, right? So how do I plug something in so that I get pi over 2 from this? Well, that's fair enough. That's simple. Well, I guess not super simple. But I have this, and I want to figure out when this equals pi over 2. Because if I do tangent of pi over 2, I get a 0 in the denominator, which means I have an asymptote. So for what x value is this equal to pi over 2? And I'll just solve. 3x plus pi equals pi over 2. Subtract pi. 3x equals negative pi over 2 divided by 3 and times 1/3. X equals negative pi over 6. So there is one of our asymptotes. So x at negative pi over 6. That was pi over 3, half of that. Well, I'm going to say this is negative pi over 6. I'm just going to say that. So that's where one of the asymptotes are. And if I have a negative pi over 6 and I know that the period is pi over 3, I can add pi over 3 to this, and that'll give me my other asymptote. So that's what I'm going to do. So what is negative pi over 6 plus pi over 3? That's just 2 pi over 6. So that would give me just positive pi over 6. Oh, great. Hold up. Did I missed something? Well, maybe not. Oh, I know what it is. I figured it out. Here we shift over pi. Okay, I think I figured it out. Maybe not. I don't know. So the other asymptote supposedly is at pi over 6. And so I want to plug in something here and something here to see. I mean, I think it should look like that, but I'm not sure. So let's figure that out. I can plug in pi over 12. Oh, that's weird. That's in the middle of that. Sorry, negative pi over 12. We can see what happens. What would that be? So I'm plugging it in. This is taking way too long. And then the tangent is on the outside, so tangent, and then negative 3, and then plus 2. So this would be, what is this, times 4? So 4 pi over 12 for 3. That would become 3 pi over 12, which is the same thing. Divide by 3, divide by 3. That would be pi over 4 times 3, so 3 pi over 4. Inside tangent, so I got to figure out what that is, 3 pi over 4. And for that, I go back to my unit circle. So this is 1 pi over 4, 2 pi over 4, 3 pi over 4. And for tangent, that's just going to be all students. That's going to be negative 1. That's going to be negative 1 for tangent. There, okay. So this becomes negative 1. I think I also messed that up when I was in class. I don't know. And then I have times negative 3, that's positive 3, plus 2. Positive 3 plus 2, well, dash 5. So 2, 3, 4, 5. All right. Sweet. And then if I plug in positive pi over 12, let's see what happens. If it's mirrored, well, I wonder if it's mirrored. How many is this away? 1, 2, 3. So my guess is 1, 2, 3. It'll be negative 1. That's my guess. Let's check it out. So what was it? 3 on the inside times x, which is pi over 12. People don't know what I'm doing, I bet. I'm plugging into that stuff first. Plus pi over 3. And then on the outside of that is my tangent, and a negative 3, and a plus 2. Okay, so that's 4 pi over 12. So that's 5 pi over 12. Ooh, I don't know what that is. 5 pi over 12. That doesn't reduce nicely yet. Oh, but then I'm timesing that by 3, so I can cancel that out. That becomes 4. So 5 pi over 4. That is on my unit circle. That I can evaluate without a calculator. And then the negative 3 and a plus 2. So 5 pi over 4. Go back to my unit circle. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. All students take, so that means tangent is positive. So it's a positive 1 there. So this is positive 1 times that negative 3 would be negative 3 plus 2 is negative 1. Ha-ha! Booyah! So this is what it actually looks like. Now some people are thinking, wait a minute, I thought we were supposed to shift. That's what I was doing wrong in class. I'm doing a terrible job at graphing this. So that's what that looks like. And you're saying, like, I thought I was supposed to shift, like, over by pi over 3. Well, that was this form. I think maybe it was shifted like this. Here, we can shift over pi, but remember, the period for tangent is pi. So if you shift it over by pi, it really just looks like the same thing. And then change stuff. So I suppose, I mean, I'm learning this. Maybe I learned it once and I forgot. Or maybe I didn't. I don't know. But when you're doing shifting, you look at it like this. I remember some confusion in my trig class in college, like about this. Now I'm addressing it, finally, 10 years later, 8 years later. I don't even know. So this corresponds to the shift. I write it like this so that I can figure out my period. Whatever, that's what it is. Takes way too long. I'm not going to put that on the test.